Okay, here we go on question 4. So this time I'm going to read it properly, make sure I do it properly. So go to rocket is initially located at this point and travels with this velocity. Units are kilometers and time is in minutes. Okay, important we remember this. All right, it's a good idea if if you're in the exam, just to highlight these things because it's going to bring these to mind when you continue through the question. So write down the vector equation of the rocket. Well, that's pretty straightforward. Remember, for the vector equation of a line, what we need is a position vector. Here's our position vector. Relative to the origin is -350, perfecto. And then plus, and time, in minutes, remember, times by the velocity vector. This is our velocity vector. Okay, you've either got a velocity vector or a displacement vector here. And this is a velocity vector, 130 and 250. Fantastic. Actually, let me just do that 0 again, because it doesn't look much like one. Actually, let's do it again. That's what makes it take longer. So what we're looking at is -350. Don't rush it. Plus t, and then the velocity vector. Like I said before, it's either velocity or a displacement vector. 20 minus 130, and then 250. Okay, so I did the same sort of 0. Why did I do that? Never mind. Anyway, move on with your life. So for B, it says find the speed of the rockets in kilometers per hour. So this is slightly different. In everything's in minutes. We've got to do it in kilometers per hour. So what do? Well, we find the speed of the rocket first. Let's just do that. And we do that using Pythagoras. This formula is actually on the formula sheet. All right, and it says Pythagoras, 3D by Pythagoras. So I'm looking at V, velocity vector, and what we need is the magnitude. So we've got the square root of -2 to 0 squared. Now remember, it's negative. Doesn't matter. When you square it, it's going to be positive. If you calculate it, doesn't show it. It just means you don't know how to use your calculator. And then -130 squared plus 250 squared. If you bang that in your calculator, you end up with, well, let's just do it, 220 squared, 130 squared. And again, you can completely ignore the negatives in this. Like I say, if you're still having trouble with that, come and ask me and I'll show you where you're going wrong. Okay, so, and then you get a surd or radical, and you turn that into a decimal. So, and it's saying here, what does it say? It says find it rounded to the nearest integer. Okay, so this point though, because we're early on, I'm going to put it as 357.5. Okay, but this is kilometers per minute. To turn it into kilometers per hour, what we need to think is if it's doing this every minute, it's 60 minutes in a hour. So all we need to do is do 60 times 357.5 kilometers per minute, and that equals, well, let me times it by 60. I'm timesing the full answer, or multiplying the full answer by 60. And we end up, now it says to the nearest integer, so we get 21449 km per hour. All right, so they're looking at us, making sure that we're converting properly. So let's go over to here. I know I said don't go down all over the place, but space is a premium. I suppose really I should have gone down here. There. Anyway, never mind. Don't judge me. So C, find the position of the rocket after 150 seconds. Well, again, we look at the initial question. This is all in kilometers per minute. We're in seconds, so we have to say, okay, 150 seconds. How many times does 60 go into that? Equals 2.5 mins. Okay, minutes. So we need to figure out where it is. So R is position, its new position is going to be -3, 5, 0, and then plus 2.5 brackets -2, 2, 0, -1, 3, 0, 2, 5, 0. Okay, when we work that out, then what do we get? Well, the top one. What have we got? We've got -3 minus 2.5 times 220. Execute. So we end up with -553. Next one, we're going to have 5 minus again 2.5 times 130 equals, so I end up with -320. Remember the top one is the is that the x coordinate and then the y coordinate. So this bottom one, the z coordinate. This is the one that's coming out of the page, and that's just 2.5 times 250. Well, we end up with 625. Okay, so these are our coordinates. So at the moment, from the origin, then we need to get, so if we're stood at the origin, we're going to go 552 kilometers left, 320 kilometers straight away, and 625 kilometers up, which is kind of what you expect a rocket to do, going more up than anywhere else really. So that's C, and in D, the last one, find the time it takes for the rocket, find the time it takes for the rocket to be 1,125 kilometers above the ground. So we only care now at this point about the Z part of our equation of the line, our vector equation of the line. So what we look at now, we say, okay, where we're going to be is find a time taken to do. So we've got 0 plus 250t. That's the Z part of our vector equation, equals 1125. So when we work that out, we do 1125 divided by 250, and this is in minutes, remember, kilometers per minute, so that's going to equal 4.5 minutes. Okay, and that's how long it's going to take it to be 1,125 kilometers above the ground. Thank you very much. Number 5 coming soon.